Just want to take a minute and recognize all of our vets out there, since this video is going to premiere on Veterans Day, November 11th. So yeah, I did 5.5 years in the Air Force as a security police officer. So now a CNC operator, and made a good choice, but don't regret anything I did in the past, and glad to serve. And I'm very appreciative to all those who preceded and have followed me. So yeah, happy Veterans Day. Okay, so today we're going to go ahead and continue the Spiru lens stabilization project, and this is kind of where we're at. There are two of these. There's a doublet and a triplet, ever so slightly different, but this aluminum piece right here is the part that I'm making right now. I thought it'd be fun to show you what's involved in the second side. So go ahead and take this guy apart. Basically what's happening is there's a spring inside of here, and this adjuster wheel will actually move this back brass piece up and down, and this is a focus mechanism basically. So as you turn this, the gap gets bigger and bigger. It's a 1 millimeter pitch, so every one revolution of this wheel will move 1 millimeter axially. So this guy comes off. There's a bronze washer, and then that guy slides off, and here we can see the spring. So this piece is what we're making. I've already gone through and done all the roughing and the first side cut on both pieces, and I finished one, and I'm going to go ahead and show you what it takes to go from this and what we go ahead and do on the back side to end up with this. So the first side cut on this piece is pretty simple. I just clamp it in a vise. I indicate about where the center of the raw material is, and I've got some adaptive clearing tool paths. And then all I did was just do some contours to establish all of these holes and features in this thing. I think I cut with a 3/4, finished the surface up here with a 3/8 end mill, flat end mill. And this bore was done with a big 3/4 end mill. And then kind of hard to see, but there's a little trough in here where that spring lives. And that little trough is cut with a 1/8 flat end mill. And then of course there's edge breaks around this boss and on the edge here. Pretty good size 1 millimeter edge break here. These are just real small, like 3 thou, just to soften that edge. But the back side of this part has some holes and the same 1 millimeter edge break and a set of countersinks as well. So, but how do you hang on to this thing, right? So that's always a challenge. So I'll show you what I do. There's many ways to do it, but you know, you could do soft jaws. You could cut some soft jaws and go ahead and pop this guy in upside down, clamp him in, and just do all the cuts. In my case, because I do so many one-off parts, it's less expensive for me to just use a sacrificial plate. So what we'll have to do is cut a hole in it so this guy can protrude through, pre-drill the 3 mounting holes and tap them, drop this guy in the plate, and we'll cut most of the material away. We'll surface it down, drill the holes and countersink them, put the screws in, and then finish all this stuff up here. Okay, here we can see the plate mounted in the vise. Went ahead and surfaced this off. I drilled the hole for that little boss to fit in, and it's got 3 tapped holes. Again, this was used for a whole bunch of other things, just a sacrificial plate. I go ahead and recycle a lot of material out of other projects that we've taken apart or dismantled, and keep it just for this. Okay, here we've got the plate. Side 1 all cut. Just going to go ahead and drop this boss into the hole, and it doesn't matter, there's not an orientation that I have to worry about, but I'll go ahead and keep it square since my tool is going to be entering off the part, doing a plunge, and then doing its cut around and then exiting off the part. I really don't like to plunge cut with big end mills in this stuff, since the only way it's going to be held is just with a couple of washers in the center. So we just position that about in the center roughly, and go underneath with this guy and tighten him down. Looks about centered. Doesn't have to be perfect. I use aluminum for these washers because if I'm not centered and my end mill comes in, it'll just cut right through that, not offer any resistance, and it'll help keep my part in tolerance. Get it good and snug down, that way it won't want to spin as we cut this guy out. Now what we got to do is set some heights. So I always want to check that my 0, and I've got my Mastercam program set with the plate top surface is 0. So I want to go ahead and verify that I'm still 0, and set my Z height at 0, and then we can go ahead and start entering programs and cutting. All right, we're going to go ahead and call up a tool. I think it's tool 15 that I'm using. It'll be the 3/8 that I'm using to bring this thing to its actual thickness, and we'll use that to verify that we're still at 0 at the top of the plate. So T15 M6. Okay, so now we're just going to go ahead and bring this guy down and touch him off on the plate. I can go ahead and just scrub that plate a little bit. It won't hurt out there. So I'm just going to spin it with my hand and bring it in until I see it just raise a chip. I'm moving 1 thou increments. I'm pretty close now. So now I'm moving in 1/10 increments until I can see it just burnish the surface. There we go. I'll back it off at 2/10, and that should be good. I'll go ahead and set that as Z0. We got our 3/4 3-flute end mill loaded up, and I've gone ahead and got my coolant situated. Should be in good shape. I've got a program loaded, and we'll go ahead and press kill. up this guy. Got my feed rate controlled down to 0 with those little knobs there, and I hit spindle stop. Takes us out of our cycle. I can resume when I'm done, but what we need to do is clear this material out of the way. This is the scariest part about doing it this way, is you've got this chunk of material right here that could go flinging. But now that we've cleared that out of the way, we can go ahead and resume. Finish the cut. I think this is the last pass anyways. So all I do is hit spindle restart and cycle start, and then bring the feed back in. So we're brought down to the height with still 10 thou to go. The scrap cutoff piece is out of the way. Now we can access the edge that we cut on the first step when the part was upside down from this, first side cut. We can access this and we can indicate that and set up our X and Y as 0. So here you can see kind of how we do that. And I've dialed this in to the tenths. She's right on. Okay, so now we've got the pre-cut edge indicated, and we've set the 0 point. Now what we're going to do is go ahead and bring this edge down to finish size, and then I'm going to stay 1 thou off of this edge, and then I'm going to come in and finish this edge right down to 0. So, and I think I got an edge break in here as well, that 1mm chamfer around the edge, and some holes. We'll drill those holes out. Gonna go grab another tool. Okay, we're all done cutting what we had to do, just so we can get these screws in. So we'll go ahead and pop those in. As I do this, I'm kind of double checking, making sure that my countersink depth is correct. These screw heads have to be flush or slightly recessed, or it'll be a problem. So we get the screws in, tighten them down, and now we can go ahead and take the big clamp off and bring this down to size. And when we do that, bring it down to size, we'll go ahead and use the same tool that we indicated 0 off and that we finished this surface with, so we're super consistent that way. So there we go. Okay, so we got the program loaded up, and this program is just going to take this thing down to its finished height and do a little edge break on here. And we're going to start with the 3/8 3 flute end mill. So I checked the program already, so we'll just go back up to the top and press kill. Takes a minute for the coolant to start. And once it gets going, I can let it roll at full speed. Okay, the part's all done, so now we just go ahead and unbolt it and give it a look. Well, there's a good visual on how I use stock to create a little fixture to hold each part as I manufacture it, to flip it over and hold it. Again, this guy had these countersunk holes for a flathead screw, and I utilized those to hold it down and then finish that last little bit. Fixturing is always one of the most difficult things to figure out. On how to make a part, and in this case, luckily we did have some holes. Sometimes you have to just toe clamp things down and move the clamp as you cut sections around, but like I said, this time I had some holes, so yeah, there's a good example.